Section 4.1.1 Angle and their measures. This section includes definition of angle, description of positive and negative angles, angle in standard position, complementary and supplementary angle, central angle, and radian measure. Ray. Ray is a half line that starts at some point and extends in one direction, indefinite. So that's ray. Angle is formed by rotating a ray at its end point. This is the end point. We call it vertex. And it's rotating like a counterclockwise. So that's the initial side, and after rotation, that's called terminal side. So the angle is formed. Positive angle. Positive angle is formed when rotation is counterclockwise, like this one. Negative angle is formed when the rotation is clockwise, like this one. So negative 45 degrees. Angle in standard position. Angle in standard position, if its vertex is at the origin, just like this one. So the initial side is on the x-axis, and the terminal side can be anywhere. So like in this case, it's this terminal side. So this angle theta is an angle in standard position. To denote angle, we can use Greek letters like alpha, beta, gamma, theta, and we can also use capital letters A, B, C. Measure of angles. There are two measures of angles. One, you can measure angles in degrees, and the other is you can measure angles in radians. In degrees, a measure of 1 degree is the 1/360 of a full rotation. So in other words, if you have a circle, if you divide circle into 360 parts, then each part is equal to 1 degree. Right angle. Right angle is like this one. Initial side is on the x-axis and the terminal side is on the y-axis. This angle is right angle and is equal to 90 degrees. Straight angle, if the initial side is on the x-axis, the positive side of x-axis, and the terminal side is on the negative side of x-axis, and that is called straight angle or 180 degree angle. Okay, here initial side is on the x-axis and the terminal side is on the y-axis, negative side, and this angle is called 270 degrees. Acute angle. Acute angle is angle between 0 and 90 degrees. Obtuse angle is angle smaller than 180 but is larger than 90 degrees. Complementary angle. To find the complementary angle, you subtract the angle from 90 degrees. Like an example, what is the complementary angle of 30 degrees? And that is 90 degrees minus 30 degrees equals 60 degrees. So if you notice, if you add 30 and 60, it becomes 90 degrees. The sum of two complementary angles is 90 degrees. Supplementary angle, to find supplementary angle of theta, you subtract theta from 180 degrees. So example, supplementary angle of 30 degrees, 180 minus 30 equals to 150. So you notice the 150 plus 30 is what? 180 degrees. Let's do example 1. Find the complement and supplement of the angle 10 degrees. Complement is 90 minus 10, 80 degrees, and supplement is 180 minus 10, 170 degrees. Determine the quadrant. in which theta lies. If the angle theta greater than 0 in degrees lies in quadrant 1 if theta is less than 90 degrees but bigger than 0 degrees. So theta will be in the quadrant 1. If theta is less than 180 but bigger than 90, then be in the second quadrant. If theta is less than 270 but more than 180 degree, then it will be quadrant 3. If theta is less than 360 but more than 270, then theta lies in quadrant 4. So let's see example. Determine the quadrant in which each angle lies. 150 degrees. As you notice, 150 degrees is bigger than 90 but less than 180. So 105 degrees lies in quadrant 2. 20 degrees. 20 degrees less than 90 but bigger than 0 is in quadrant 1. 190 degrees is bigger than 180 degrees but less than 270, so it's quadrant 3. 278. 278 degrees less than 360 but bigger than 270, so it should lie in quadrant 4. What is central angle? Well, an angle whose vertex is at the center of the circle. And so in this example, alpha is the central angle because its vertex is at the center of this circle. Angle in radian measure. A central angle, like here theta, intercepts an arc that's on the circle, and if this is equal to the radius, then this theta equals to 1 radians. Okay. So one full rotation of ray about its endpoints. So let's see if you start from this point, and you go all the way, and you come back. That's one full rotation, and that's equal to 2 pi, which is equal to 360 degrees. And if you go from this point, and then rotate this one, then it's what? Right angle, which is pivot. And if you rotate this initial side all the way down here, then this will be a straight angle, and that's equals to pi. Because to determine the quadrant in which theta lies, when theta is in radians, so you have to check if theta is between 0 and pi over 2, then theta is in quadrant 1. If theta is between pi over 2 and pi, then theta is in quadrant 2. If theta is between pi and 3 pi over 2, then theta must be in quadrant 3. If theta is between 3 pi over 2 and 2 pi, then theta must lie in quadrant 4. Example. So we're given pi over 6 and we want to know which quadrant theta lies. Well, pi over 6 looks like a less than pi over 2 but bigger than 0. So the answer will be quadrant 1. Minus 5 pi over 6. But to answer this question, either you draw this one, or what you do is you just add 2 pi and see what you get. So if you add 2 pi, you get 7 pi over 6. So it looks like 7 pi over 6 is bigger than pi, but less than 3 pi over 2. So minus 5 over 6 is in quadrant 3.